So we're in Geometry Chapter 6 on 6.1. We're going to talk about if you, in a triangle, all the angles added together equal how many degrees? So if I add all three angles together in a triangle, how many degrees do I get? And that should be a refresher, 180 degrees. Moving on to 6.1. Polygons. A blank is a plane figure that meets the following conditions, and that is called a polygon. So a polygon is a plane figure that meets the following conditions. All right. It is formed by three or more segments called sides. Each side intersects at exactly two other sides, one at each endpoint. Okay, in other words, I had a triangle. Here's a side. All right, the other side, they have to intersect at the endpoints. They have to be close. All right, the vertex is each endpoint, and that's the word that we'll be using for endpoints. And a type of polygon that extends the sides so that no line goes inside the figure is called a convex polygon. And one that would look like that is a regular shape, like a square. If I extended the sides of the square, none of those sides would intersect inside of that square that I made. Okay? Something called concave is the direct opposite of it. Concave is a type of polygon that if the sides were extended, the line would go inside of the figure. So something that's kind of irregular shaped. Okay, so if you had one line that would go inside, like these don't. They stay on the outside of the figure, no big deal. But if I extended this line right here, look, this piece right here goes inside the figure. Therefore, it makes it concave. All right, a polygon is equilateral if all the sides are congruent. We've talked about that before with a triangle, but this works with any all right, and a polygon is equiangular if all its interior angles are congruent. So this one's angles, the one equilateral is sides. And if both of those occur, they're going to be called a regular polygon. We'll get to that in a little bit. The diagonal of a polygon is a segment that connects any two non-consecutive vertices. Non-consecutive means sides that are not right beside each other, angles that are not right beside each other. And a parallelogram is a quadrilateral with both pairs of opposite sides that are parallel. So, for example, like a rectangle. These sides are parallel with each other. And these sides are parallel with each other. So the opposite sides are parallel. So there's a parallelogram. All right, the interior angle sum theorem. To figure out how many, if you added up all your angles inside of a figure, how many degrees they would add up to be, take the number of sides minus 2, that answer times 180. Remember a triangle has three sides. 3 minus 2 is 1. 1 times 180 is 180. But an exterior angle sum theorem means that no matter what shape you have, if you add up all the exterior angles of a figure, it's always going to be 360 degrees. All right, remember I talked about regular polygons? Regular polygons are both equiangular and equilateral. They have to fit both of those. All right, to find one interior angle of a regular polygon, you're going to use the interior angle sum theorem, but then divide by the number of sides. So remember that is n minus 2 times 180 divided by n. And this is only to find one interior angle, not to find the sum of the angles, but to find one. And it has to be of a regular polygon, not any shape. All right, to find one of the exterior angles of a regular polygon, it's 360 because that's all the exterior angles, divided by the number of sides of your figure. And that's only to find one exterior angle, and it has to be a regular polygon. All right, so we talked about shapes: triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, and decagon. Well, the number of sides, you know, 3 is a triangle, 4 is quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 is a heptagon, 8 is an octagon, 9 is a nonagon, 10 is a decagon. And there's others. Dodecagon is another common one, that's 12. Anything past that, you may see an entagon, like 13agon. That means it has 13 sides. Okay, so just be aware that there are names for them, but they get kind of large and we don't talk about them, so we'll do that a lot of times. Shorten it. Quadrilaterals. A quadrilateral is a closed geometric figure with 4 sides and 4 vertices. Any 2 sides, vertices, or angles of a quadrilateral are said to be consecutive or opposite of each other. Okay? So, for example, if I had a triangle, if I was looking at this point here, okay? Well, consecutive vertices would be B and D. Opposite vertice would be C. Consecutive sides would be AB and AD. But opposite sides of AB would be the one across from it, CD. And the segment joining any 2 non-consecutive vertices in a quadrilateral is called a diagonal. So, for example, in that picture that I talked about, the consecutive vertices were B and D. Well, the only one diagonal that you can have with A is going to be from A to C, the segment AC. Of course, there's another diagonal across from it. So here's some examples. We're going to name all pairs of opposite sides. They get kind of intense. So we have W, Z, and X, Y. They're opposite, sides opposite, and you must name them like segments. And WX and ZY. All right. Then the second part, we're going to name all pairs of consecutive angles. Well, consecutive means the very next. So angle W and angle Z, angle Z and angle Y, angle Y and angle X. You must have the angle symbol. Angle X and angle W. Then we're going to name the diagonals. And the diagonals would be ZX and WY. Name all pairs of consecutive vertices would be W and Z, Z and Y, Y and X, X and W. Name all pairs of opposite angles, angle W and angle Y, angle Z and angle X. And number 6, find the missing measures in each figure. Well, again, if you didn't know how many degrees a quadrilateral adds up, n minus 2 times 180. Well, it's 4-sided, so 4 minus 2 times 180. Well, 4 minus 2 is 2, and 2 times 180 equals 360 degrees. So all 4 angles in these quadrilaterals add up to be 360. So add them together. 91 plus 133 plus 89 plus x all equal 360 degrees. Combine like terms. So you get 313 plus x equals 360. Subtract 313 from both sides. And you get x equals 47. And I didn't write degrees because x already has a degree in the problem. Just solving for x. Same with this. 360 equals all of these added together. Combine like terms. Subtract the 282 from both sides. So x equals 78. Moving down to 89. Again, all four angles add up to be 360. So we know that 360 equals x plus 44 plus 137 plus 42. We combine like terms. Subtract the 223 from both sides. And x equals 137. All right, 9, notice I have two different measures that are missing. But again, we know that everything added together, an x plus 125 plus a 105 plus an x plus 50, they all add up to be 360. Combine like terms. Subtract the 280 from both sides. And divide by 2. So x is 40. So then I need to find x plus 50. Okay, so this one's 90 degrees. Number 10. Again, same kind of concept. We add them all together. Be careful that you have 4 x's. 3x plus 1x is 4x. Subtract the 212 from both sides. Divide by 4. Okay, so now I found x is 37 degrees. But this angle measurement here is 3 times x. So 3 times x equals 3 times 37, which equals 111. So this angle right here is 111 degrees. On 11, you've got x minus 30 plus x minus 30 plus x, all equals 360 degrees. Combine like terms. Oops, 4x minus 60 equals 360. You add 60 to both sides and divide by 4. So x equals 105, and then you have the x minus 30, which is 105 minus 30, which gives you 75 degrees. So these are 75 degrees each, and these are 105 each. All right, parallelograms is a special kind of quadrilateral in which both pairs of opposite sides are parallel. All right, so a rectangle, a square, a rhombus, they're considered parallelograms. The way to concern parallelograms, they have to have these. Opposite sides of parallelograms are congruent. Okay? If you know that, then it's a parallelogram. If you know opposite angles of a parallelogram are congruent, it's a parallelogram. All right? We know that if it's a parallelogram, consecutive angles of a parallelogram add up to be 180. They're supplementary. And we know that in a parallelogram, the diagonals of the parallelogram bisect each other, creating two congruent triangles. So in other words, opposite sides of a parallelogram are congruent. So parallelogram, these sides are parallel, they also have to be congruent. These sides are parallel, and they also have to be congruent. Opposite angles of a parallelogram are congruent. So if it tells you that it's a parallelogram, And you know that opposite angles are congruent. This angle and that angle are congruent. These angles right here are congruent with that. All right, consecutive angles of a parallelogram are supplementary. So that means that they're not congruent, but these two angles added together equal 180 degrees. All right, and the diagonals of a parallelogram bisect each other, creating a 90-degree angle. Excuse me, bisect each other, cutting them in half. We know that this side and this side are equal, and this side are equal. They do not have to be, the diagonals do not have to be equal to each other. They do have to have that. They bisect, they're cut in half. All right, so given that information, if the quadrilateral is a parallelogram, find the values of x, y, and z. All right, so it is a parallelogram, it tells me that. Find the values of x, y, and z. Well, the easiest one to find, this is 29. Remember parallel lines and transversals? One's opposite of it, alternate interior angle. They're going to be equal. So x equals 29 degrees. All right. Also here, this is a straight line. That means it adds up to be 180. So 180 equals 78 plus z. Subtract 78 from both sides. And I get z equals 102 degrees. Now I need to find y. Oh, here's a triangle. You see my triangle? And in a triangle, all three angles add up to be 180. 180 equals y plus the x, which is 29, plus the 78. So I subtract those, and I get 73 equals my y. 73 degrees. On 2. Again, remember, alternate interior angles, they're going to be the same. So y equals 44 degrees. X is going to be the same as 31. So x equals 31 degrees. And z is going to be the same as the one over here. So z equals 105 degrees. Last one. On these, remember, consecutive angles are supplementary. So x plus that add up to be, all right, so you add up to equal 180. They're supplementary. So, but we had to find x first. Remember, parallelograms, they're the same. So x equals 73. Now that I know it's 73, I can find this measurement right here, which is 180 minus the 73, so they're supplementary. And I get 107. So that's that angle measurement here is 107, right? And opposite angles are the same or same as. These are consecutive angles, and they add up to 180, so that would be z. So z equals 107 degrees. Now y may be a little tricky. Y and x are alternate interior angles also. So y is also going to be 73 degrees. In a parallelogram, ABCD measure at the angles A is 3x, B is 4x plus 40. Find the measures of angles A, B, C, and D. So I like to draw a little picture, and I just label it A, B, C, D. They should go in that order as you read it. A is 3x, B is 4x plus 40, and that's all we know. But we know that consecutive angles add up to be 180, right? So 3x plus 4x plus 40 have to equal 180. Combine like terms. 7x plus 40 equals 180. Subtract the 40 from both sides. 7x equals 140. Divide by 7 to both sides. X equals 20. All right, so now we found what x is. We need to find the angle measurement. Well, angle A is going to be the same as angle C because they're opposite angles. And they both equal 3x. Well, we know that x is 20, so we have 3 times 20, which is 60 degrees. And we know that angle B is equal to angle D because they're opposite angles. And they are 4 times x plus 40, which means that we have 4 times 20 plus 40, which is 80 plus 40, which equals 120 degrees. All right, in a parallelogram RSTV, the diagonals RT and VS intersect at Q. So you've got this picture. You've got RSTV. You're talking about the diagonals. They intersect at Q. Remember what we know about diagonals of a parallelogram? That these are equal to each other. Now, given the information, QT is 3x plus 15. And RQ is 5x plus 1. It wants me to find the measurement of QT. But all I know is that RQ and QT are equal. They're the same length. And if they're equal, you set them equal to each other. And solve for x. Subtract the 3x from both sides. Move the 1 to the other side. Divide by 2. So we get x is 7, but that's not what it asks for. It asks to find QT. And QT is 3x plus 15. So really it's 3 times 7 plus 15, which is 21 plus 15, which gives you 36. Now it's not degrees because we're talking about a length. So it's just 36 units. All right, on these, explain why it's impossible for each figure to be a parallelogram. Well, look at it. Opposite sides have to be congruent. Are they? No. I'm going to use shorthand. So opposite sides are not congruent. How about these? Opposite angles have to be what? Opposite angles have to be congruent, are they? Shorthand for angles. Opposite angles are not congruent, not equal.